now here we have some more sea ice forming in this glass here. In fact, we have a bit of frost forming because there's clearly some moisture in the air of the room. And the temperature of the glass is now below the dew point of air for this room. What we're going to do is break this up. We're going to separate out some of these pieces of sea ice that formed here from the dry ice. As you can see, the sea ice formation can create quite a bit of ice and remove quite a bit of material from the water. And we're still getting evaporation in our subtropical high over there. Now we do have evaporation on tropical oceans, but there's rainfall outweighs the evaporation, so there's a net input of fresh water in the very low latitudes near the ITCZ. Wow, this is really slushy. And just because we have some slush here, I'm going to have everyone's favorite color to the slush. Yellow, everyone's favorite color for dye. Dyeing water and water-related things. So there we go. Oh, there we go. We got it. Now, meanwhile, we can look back at the polar water, the brine rejection. We can see it very clearly, this beautiful downward plume of deep water formation from just a small pod of the brine rejected water. Ooh, I'm hoping we caught that on the camera, but wow, this is the best that's actually ever come out, so we're doing something right here. So what we see here is just, in the meantime, as we've been sort of removing some of the slush and dyeing it the color of snow you probably don't want to go too near in the winter. As the sea ice was forming on the bottom of this little dish that's exposed to cold air, the ice has concentrated the salt water, and we've gotten brine rejected, and what's happened is the remaining water is both cold and salty, extra salty, and that extra saltiness has sent this water to the bottom of the tank in a pretty substantial form. And you can see this process is quite a vigorous one, and can move water actually to the bottom of the ocean quite quickly. In fact, I'm going to add a couple more drops to this system just because I'm so impressed with how nicely it's operating. Normally it does not work this well. Well, when I try to do this in a classroom, probably because I'm less focused. Right. Yeah, you can see it really rapidly as the sea ice forms. The brine rejected, the extra salty water that's rejected as the ice formation preferentially favors the takes away the fresh water. Do not do what I just did there. Causes the plume, creates this very vigorous plume of salty water going to the bottom. You can really see this, and we'll zoom in on this because we're really starting to see how vigorous. And this happens both in the Arctic and Antarctic along the any place sea ice is forming. And in fact, this plume of cold, salty water forms so vigorously in the Antarctic that it actually protects many of the ice streams and ice sheets that drain into the Southern Ocean from being melted by the oceans, by ocean water, because that plume goes downward. Now that we got this vigorous plume, though, of, we call this stuff over here, we call it the Antarctic bottom water, or AABW. And this stuff will, given a chance, flow all the way down. Bottom water. Whereas what we're seeing over here, where you have in the North Atlantic, off the coast of Greenland, you're getting North Atlantic deep water. Okay, that has really evaporated pretty nicely. I'm very pleased. I can't wait to see how this will turn out. Call this North Atlantic deep water. This is also what happens to a good bit of the Gulf, some of the Gulf Stream waters as they, so the North Atlantic will be mostly NADW, and then at some point this tongue of North Atlantic deep water will overlap the Antarctic bottom water. The general gist of this is that our deep oceans are quite cold regardless of which basin you are. Now the one place where the deep ocean is not quite as cold